Hello friend. Now we are going to start the inductance and we will calculate the electrical power and the work done. Electrical work done and electrical power related to the passive element of the inductor. That is the property known as inductance. So before calculating the inductance, first of all we know what is inductor. Inductor is nothing but the property of a material by virtue of which it opposes the changing current. जो मतलब ये coil material means जो coil है हमारा, है ना. और coil क्या होता है? Nothing but the condensed wounded. That is जब कंडक्टर को हम wound करते हैं just like in a spring. So that is called basically a coil. Here we will see this is a coil that is nothing but the wounded shape like in a spring. Okay, that is coil. So property of a material which is coil by virtue of which it opposes the change in current, that is known as inductor, and the property is called inductance. So now let us assume that we take the inductor having the inductance cell, current flow through the inductor known as I, small I, and the voltage across this one is V. The voltage across the inductor is small v. Now by the first law of electromagnetic, what it says that when a time varying current is flow through the coil, a time varying coil, a time varying magnetic field or flux is produced by Faraday's first law. मतलब कि अगर time varying है, IT is time varying, current is passed through the inductor, then a time varying magnetic flux will be generated. Okay, now let us see. So total flux produced in a coil, how much? Ni. This is now see, when we are passing the current through this coil, we are getting the time varying magnetic flux. So the total flux produced in a coil, which is given by total flux coil is given by zeta equals to n into phi. Okay, where n is the number of turn. किसका turn? coil का turn. कितना term? जैसे 1 term, 2 term, 2 term, 3 term, 4 term, 5 term. Okay, यहाँ पे तो 4 turn. Okay, similarly number of turn where n is the nothing but number of turn and phi is the flux per turn. मतलब एक टर्न में एक रहेगा, तो total flux for one turn is nothing but number of turn is 1 into phi. Okay, that is phi. So if we calculate for the total flux produced in a coil, which is given by zeta equals to n into phi, where n is the number of turns of the coil and phi is the flux per unit turns. Now for time varying flux, zeta is nothing but where n is constant. This is for time varying total number of flux. Okay, now see, zeta is for the n terms is n into phi, और इसका जो यूनिट होता है that is Weber, which is nothing but written by SI unit W Weber होता है. Okay, now you know one thing, that is this total flux produced is directly proportional to what? Current flowing through the conductor, of course. That means total flux is directly proportional to total flux produced. is directly proportional to the current. Okay, that means phi is directly proportional to y. For removing the constant, this proportionality, what we will do, we will just take some other constant, which is nothing but L. Now this is the formula, zeta equals to L into I, where L is the inductance, that's the parameter of the coil. Okay, now we can write from here that also N phi equals to Li and phi equals to Li by N. Flux is equals to inductance into current upon number of turns. So for single number of turns, flux is Li. Okay, flux is Li. Okay, inductance into current. Now by this Friday second law from the Friday second law, Friday second law, so what state that? Friday second law state that the voltage drop across the coil, that is given by V, voltage drop across the coil, that is given by d zeta beta dt, change in the total flux with respect to time by the Friday law of induction from the second law. Okay, we can substitute the value of zeta here, that is how much d from here, Li by dt. If we differentiate this product, like d into u v is how much, d by dt equals to u dv dt plus v du by dt upon how much? This is the formula for this one. This is not open, this is actually differentiation. Okay, now we will get Li di by dt plus di dl by dt, that is nothing but the voltage, that is the voltage drop, across the coil from the second law of Friday law of induction. We will get this one. But one thing is sure, that this will be valid only when t is constant. This equation will be valid when t is constant only. Okay, t is only constant. So in the entire network theory, in the entire network analysis theory, temperature is always assumed as a constant, and hence length in the entire, it is always assumed as a constant in the entire network theory. So what? The conductivity, the surface area, okay, they are kept constant also. They are kept constant. That's why RLC is also constant. RLC is also constant, na? And RLC is constant, that means differentiation of constant is 0. Therefore B equals to L di by dt. This is our equation. Okay, when temperature is constant, this will be valid. Now we'll see again. Now see, dl by dt, that is 0. Why? Because we assume temperature is constant. Because in any network theory, temperature is always assumed as a constant, and hence the conductivity, the cross section area and the length kept as a constant. So RLC will be always time invariant. That means its value remain same throughout the time. Okay, That means this is will be assumed as a constant, and differentiation of the constant as refers to time, that is 0. Therefore we eliminate this term. We have eliminated this term, and only this term is applicable only till the temperature is kept as a constant. Now V equals to LdI by dt. We can take Ti by di here. We can take di equals to 1 by L V dt di. Now if we take the value of I by integrating from minus infinity to t into V by dt, why we have taken t? Because we have taken t because t is the till today time. If on this axis, if this is an axis, okay, this is a past time, this is the future, okay, and this is the today, t at finite time. If this is for memory, past, okay, this is past or memory, okay. If we take here 0, if this is minus sigma, this is sigma plus, okay, today, and it is infinity, that is plus minus infinity. Let us assume it is date of birth and date of death. So whatever we are doing, whatever we are calculating for the till the time t, not for the date of death. So we are assuming here from the minus infinity to t only we are calculating. That is mainly for this, from between t to this, for future. No prediction, not about future. Now let's see. We know that P equals to VI, power equals to voltage into time, and voltage is given by L di by dt into I. This is one important formula, Li di by dt. Now, where P is the instantaneous power and the unit is watt. Okay, now for calculation of the work, we know that P equals to VI, and the work is nothing but dP butta dt. That is nothing but power is nothing but rate of doing work. Power is nothing but rate of doing work, and W can be calculated by integrating the power. If we talk about the invariant, time invariant, then PT dt. Okay, PT dt. Okay, we have taken. Now we can put the value of P into here. So what we will get? We will get work done equals to Li di by dt, Li di by dt, instead of pt we have got this one, and dt. Okay, and its unit is of course joule. It is work now. Work unit is joule. Now this is a formula, important formula. Questions were asked sometime. Now see, we know that power equals to Li, power equals to Li, from here Li di by dt. Okay, we can also write here, if we integrate the I with respect to t, what we will get? We will get Li I square what we will get? For in this one, what we will get? We will get half Li square. Okay, half or d by dt half Li square. If you just differentiate this term half Li square, we will get this one. Okay, now since we know that W equals to pdt, and okay, joules is this one, so we can write W equals to P d by dt. We can put this one here. Okay, we can write here. Now, okay, now what we will get? Finally, dt cancel out, so we will get W equals to half Li time variant between T1 and T2. Okay, half Li, this one cancel out, integration differential cancel out. Okay, and this term will be constant, so come out an Li square, and the differentiation of Li square is how much? 2 into we'll differentiate, we will just get this one. Okay, now if there is this one, we will calculate W equals to half L is constant, so we take out I T2 minus I T1. This one is the formula. If the current at T1 is 0, let us assume that current at T1 is 0. Can IT current is 0, then W equals to half L I T2. That is nothing but instantaneous work done, and its energy is 0. Because this one is 0, this means energy is 0. For instantaneous work, we will call this one. That means energy stored in inductor at any instant. Energy stored in inductor at any instant will depend on current flowing. Okay, na? Current flowing, though the inductor at that instant, okay, मतलब एनर्जी जो स्टोर होगा कंडक्टर में किसी भी इंस्टेंट पे, दैट विल डिपेंड अपॉन द करंट फ्लोइंग थ्रू दैट इंडक्टर एट दैट इंस्टेंट, उस समय में. मतलब ये इंडक्टर है हमारा, करंट फ्लो हो रहा है, तो जो वर्क डाउन होगा, जो एनर्जी स्टोर होगा उसमें, एनर्जी जो स्टोर होगा इन इट्स कंडक्टर, वो इंस्टेंटली वो डिपेंड करेगा करंट कितना फ्लो कर रहा है इसके इधर इंस्टेंट में, है ना. दिस इज द टोटल एनर्जी स्टोर by the inductor, and that is nothing but the total energy stored by an inductor from infinite minus to the present time t. Okay, let us see the last one. If we plot the characteristic graph, will you assume this one is okay. Let's now see how to calculate the zeta I characteristics for the inductance. If we draw the chart, okay, if we take this one is current, okay, we know from the previous that zeta is nothing but Li. Li means inductance into current, which is, if we compare this one with y equals to mx, okay, where m is slope, so L is slope, y is what? Dependent, x is independent. So here I is independent and phi is, the zeta is dependent on whom? On Li and Li simply. So we will take Okay, now this is the origin, and slope of this will be this one, linear. Why linear? This is from this equation, it's clear, linear. That is, it will be same as R, but in same as R resistance, but in zeta I plane. Achha. Here what we are assuming from this equation or the characteristics, that L is linear. Why linear? It passes through the, its graph is passes through the origin. Okay, linear. Second one, it is linear. Second one, what? It's passive. It's passive circuit. Now, of course, passive. Okay, and time variant. For every value of t, it's remain what? Same. So time invariant. Okay, passive and linear. Passive, linear. So we'll see in the next lecture the capacitor mainly. Okay, thank you.